In a water polo match, a tie at the end of 2 overtime periods leads to a shootout with 5 shots taken by each team from the penalty mark, and each shot must be taken by a different player. How many ways can 5 players be selected from the 7 eligible players? For the 5 selected players, how many ways can they be designated as first, second, third, fourth, and fifth? Now, permutations of items are arrangements in which different sequences of the same items are counted separately. Combinations of items are arrangements in which different sequences of the same items are counted as being the same. This situation of selecting 5 players from the 7 eligible players represents a combination, because rearrangements of the selected players still results in the same group of players, so order does not count. Now, recall the combinations rule. When n different items are available, but only r of them are selected without replacement, the number of different combinations, where order does not matter, is found as follows. So we have n factorial over the quantity n minus r factorial times r factorial. Now the problem is looking for different ways of choosing 5 players out of the 7 eligible players placed in any order. This means that r is going to equal 5 and n is equal to 7. So we're going to substitute those values for r and n in the formula for the combinations. So we know that n is 7 and we know that r is 5, so we have 7 factorial divided by 7 minus 5 factorial times 5 factorial. Well, the first thing we're going to do is what we have inside parentheses. So 7 minus 5 factorial is going to give us 2 factorial. And we know that 5 factorial is larger than 2 factorial, so our numerator just needs to go to 5 factorial. So we have 7 times 6 times 5 factorial over 2 factorial times 5 factorial. Now 2 factorial is the same thing as 2 times 1, so we can figure out what we need to simplify here. So we can simplify the 5 factorial, and then we know that 2 can go into 6 3 times. So in the numerator we have 7 times 3 times 1, and in the denominator we have 1 times 1 times 1, and therefore 7 times 3 is going to give us 21. Therefore, there are 21 ways to select 5 players from a team of 7 to take the shots. Now recall that n factorial is the number of different arrangements of n items when all n of them are selected. The number of ways to designate the 5 players as first, second, third, fourth, and fifth is denoted as 5 factorial. And so out of those 5 players that are selected, they can be designated as first, second, third, fourth, and fifth, which can be denoted by the following. 5 factorial is equal to 5 times 4 times 3 times 2 times 1, which is equal to 120 different ways. So in this water polo match, 5 players can be selected from 7 eligible players in 21 different ways. And out of those 5 players that are selected, they can be designated as first, second, third, fourth, and fifth in 120 different ways.